Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Edo and Søren, welcome to the program.
Thank you very much, Alan and Joel.
Thank you both.
We have some really exciting news from you from the field, but first I want to start with the problem, which a lot of operators have right now, which is this blade root insert issue, which is really critical to blades. And Edo, you're the creator of the device that's going to save a lot of blades. You want to talk about what happens when these blade root bushings fail?
What we have seen is that it especially concerns polyester type of blades. And what we see is that bushings and composites, they are not attached to each other anymore. And after a while, blades are simply flying off. That's the whole problem, of course. The fact is that if we are working with polyesters, they already have during the process, the curing process, they have already curing shrinkages. So we have already curing shrinkages, which means we have already initial micro cracking going on the interface between the bushing and the laminate around it. And that reduces the surface carrying area. And by doing so, because we have less surface area that can transfer the loads from the hub, from the blade to the hub, we have limited amount of years on running. So we are reducing the amount of years that the blades are on the turbine safely.
This problem is compounding right now simply because there's a lot of the global wind turbine fleet that's starting to age, right? Like we went through a big push in, the early 2000s, 2010s, 2020s to now, where, if you look at the country of Spain, we hear that regularly, Alan, is, hey, we're getting to the end of life. We're close to the end of life. Then there's people saying, what is the remaining useful life? Where are we at? And this is one of those issues where it can develop rapidly, right? So if there's an issue, if you catch it in time, great, you're good. But it can develop rapidly, and that can lead to catastrophic losses. But I guess one of the questions I want to ask you, and you guys, of course, have done some commercial here, how many turbines do you think are affected by this globally, affected by this root bushing issues?
Oh, that's a good one. If I talk a number of blades, at the moment we are more or less at a ballpoint figure about 40,000 blades.
Wow.
Worldwide. So we see many in US, we see many in South America, and we see also in Southeast Asia, like India. And those blades are running, let's say, from 10 years, 12 years, and some of them also after 6 years.
And a lot of manufacturing blades happens in multiple sites, right? So if you have a particular OEM wind turbine, you may have a variety of different blades on your site. You typically do. Some of them are polyester, some of them may be epoxy, but it's the polyester ones we need to pay attention to first, right?
Correct. The one we are concentrating on with our solution are dealing with polyester blades. Because there we see the problem, especially in the interface layer. There are also root problems with epoxy types, but they are from a different level.
So the thing that we're looking for when we start to see the problem, so if I'm an operator and I have technicians out in the field and they're looking at blades from the ground typically very quickly, what are the first signs that you have problems with the bushings?
What we generally see, the first signs is that there is a cracking going on in the sealing, which is between the blade and the pitch bearing. So if you go up tower as a service guy, then look for those initial cracks. And if you see cracking in that sealant, then remove the sealant just with a knife and go with a filler gauge to see if you're capping going on between the root laminate, so between the bushing and the pitch bearing.
So that sealant or gasket between the blade and the pitch bearing shouldn't be moving or shouldn't have flexed. It shouldn't have broken. It can flex. It's made to flex a little bit, but if it breaks, it tells you there's too much stress on that sealant. That's really the first sign.
That's really the first sign. Then you still have time, but then you have to start monitoring.
And the monitoring is telling you what?
Once you notice this. What you have to do is, for example, you're positioning a leading edge under tensile loading of the dead weight. Then you measure a cap. Then you pitch the blade that side is down, so it's feeling a compressive loading. And then you can see if there is a difference. So what you're doing is you're measuring the variable cap. So not a static cap, but the variation of the capping due to its own weight of the blade. And that is a sign that movement is going on.
So you'll see compression versus tension, that gap get larger and smaller. There is always some movement in that gap, but it's very limited. What typically is a threshold where you say, if it's beyond a couple of millimeters, that's a problem? Where does that dimensional gap become an issue?
With our present customers, we are saying 1 millimeter, and you have to hoist the blade down.
1 millimeter is 40 thousandths of an inch. That's not very much.
If it's, for example, 5 millimeters, I mean, it's not. You're in the bad stage that within 3 months your blade could fly off. And if you are in the range of 1 millimeter, the nice thing on that is that you have a limited amount of bushings which needs to be replaced. So you're limiting the effect of the repair.
So, but that's the big thing here, right? So catching it early, it's like anything in blades. We talk about this. We've been beating this horse for a long time. Catch it early, fix it early, or you're going to be in a bad state. Because I mean, the worst thing that happens here, of course, is a safety issue, loss of life, or anything like that. But what we have seen, blade breaks, blade comes down, hits the tower. Then the tower comes down, then you're replacing an entire turbine. And that's horrible for the operator, the industry, everything in general. But if you catch it early, now each blade has, depending on the model, the make, the design, 60 to 80 bushings, 60 to 100 bushings. What is that number?
92, for example, or 74, or in that area.
Right. So when your solution is engaged, when you have to bring the blade down tower and then fix it. If you catch it early, are you talking we're fixing 6 of these? We're fixing 40 of these? What does it usually look like?
It's in the area of 24 to 30.
Okay.
The nice thing is on that, if we're working with a drilling machine, we can do that in 24 hours drilling. So limited time of taking out the bushings. And if we would wait longer and we need to repair 60 bushings, it takes, let's say, 60 hours to drill out. So to lower the cost of the repair, because it's like a chain reaction. Once it starts, it grows. To lower the amount of the repair and the cost of the repair, let's not wait too long.
Okay, so that's a really good input into this discussion, because I think a lot of operators assume if I have to do this repair or replace the bushings, I'm replacing a number of bushings regardless of the level of damage, because they're going to fail eventually. But what you're saying is that it starts in a highly loaded couple of bushings and spreads from there. If you can fix or upgrade those particular bushings, then the remaining bushings may be okay.
Correct, because there is always a highly loaded, like you said, and there's always a side which is more tensile loaded, and the other side is more compressive loaded. And especially the tensile loaded part is more severely for the fatigue.
The other side of this is a blade replacement, right? So you're either gonna do something like this, or you're gonna replace the blade. But now, again, we're talking about this aging fleet's remaining useful life, what spares look like out in the field. A lot of these turbines, spares are not readily available for them, right? We're talking about different markets. Like you guys just executed. We're going to talk about this a little bit, but you just executed this amazing project over in the APAC region. It's not easy to get blades shipped over there, or like in Australia or South America. Like in the States, we're kind of lucky. People don't realize this, but we're kind of lucky that we have a fleet of 75,000 turbines, because there are spares around for some things. However, as these blades get older, like nobody's going to do you a run of a 12-year-old, 15-year-old blade. Like it's whatever's on the ground around the world is what we have, and that is it. And then in composites, again, everything can be repaired, but it's just how much. What is the economic case for it? So you guys are building that economic case to make this make sense.
A new blade, let's have the old-fashioned prices of 10 euros per kilo or whatever, and you have a blade of 15 tons. That will cost you like 150,000 euros as a new blade. you already paid for that price. Then you have to do it a second time. It's not only that, it's also the waiting time. If you have to wait for 1 year, your loss in revenue is also, let's say, like 100, 150, maybe 200,000, depending on your feed-in tariffs that you get. That's also a loss. So the total thing will cost you already like easily like 200, 300,000 euros for one turbine, right? Or for one rotor blade. If you do a repair, then this repair, it will cost you like a fraction of that. It will cost you maybe like 30, 40,000 euros.
Yeah, and the reality is when you replace one blade, you normally are replacing all three. I mean, unless you can find a matching, a good. Well, you get lucky and you find one blade that has the weight certificate and a bending moment certificate that matches your other two that are up tower. Pretty rare. More than likely, you're getting all three new blades. So then all of a sudden, your 150 turns into 450 before you even start it.
Absolutely.
And that's if you can get a replacement blade, because if you need to go back to a manufacturer, right, they will not sell you that blade for the original 150,000 euros. So if they at all have a mold before they get it started up and all the initial cost in getting that up and running, you are looking at 2, 3, 4 times the price of the new blade. So it really adds up if you have to replace. And there's of course also the whole discussion right now with the old blades and all the waste it's creating. So from an environmental perspective, it's also a huge benefit to repair instead of replace. But the financial is just basically a no-brainer, right?
Oh yeah, the financials make total sense. And this is where we're going to get to the solution from We4Ce, which is called Refit, which is a bushing upgrade, and the workings together of two separate companies. So we have We4Ce, which is based in the Netherlands, of course, and then we have Søren and CNC Onsite, which is based in Denmark. So they're really relatively close to one another, and both companies are powerhouses in wind and fixing wind and making it more efficient and getting our turbines optimized for long-term duration, which is what we in the States have not been doing, but that's going to rapidly change in the next couple of months. So this refit solution does make a lot of sense to me, just because the demand is going to be there and we need to have some way of doing this. And this is what I want to talk to both of you about, because understanding how to replace these bushings, it seems at first like it's an impossible task, but you brought two powerhouses together to solve this problem. You want to discuss how the two companies work together, We4Ce and CNC Onsite, and how this repair, rework is accomplished?
I think if we take it back a step, we at CNC Onsite was originally involved in a blade repair project way before the Corona situation. So we had worked on a machine and made some tests in our workshop on this repair, drilling out bushings. Then Corona came and the project was stopped and never restarted again. So about 4 years, pretty much to the date, because it was at the Husum Wind Fair, which is now coming up again in 1.5 weeks. We met We4Ce. So we had this drilling technology sitting there, and I walked around and I saw these nice bushings and a couple of nice gentlemen standing there. So I approached Edo and Arnold and said, "Hey guys, this looks nice. What is it?" And we started talking about that they actually had the bushing technology ready. They needed someone who could drill out the old ones, and we had the technology to drill out the old ones, and needed someone who could insert those replacement bushings. So it was actually a very good fit. And then the whole cooperation just started off basically on trust. I mean, we signed the NDA and stuff like that, but we just trusted each other and moved forward. And it took some time before getting to the first customer. Also, what you mentioned in the beginning, right, Alan, that it looks nice, but has it been done before? We've heard that question a lot of times. So it took some time before we got through all the testing and stuff like that. But now it's up and running and works really well.
at a certain point, the customer said to us, if you can show a test with this number of cycles in fatigue, it was something like a certain level and 1 million cycles test. If you can show that to me, then we will sign the contract. So we sent 2 coupons, one to a Dutch institute, independent, one to a German institute who was doing coupon testings. And we said, okay, run them off both for 1 million cycles. And they had the same result. So, and both have reached the 1 million cycles. So we said to the customers, we did not provide 1 coupon with 1 million cycles, but 2 for you to make sure, and also at different test institute. And then they signed the contract, and it all went very fast after that.
Well, yeah, as soon as you can show the technology works in the laboratory, the next step is to get it deployed. So the process works sort of like this, and stop me if I'm too far off, because I've had it explained to me very slowly. Edo has done this very carefully. So let's see if I can explain it to the teacher. I'm going to remove the blade off. I'm going to bring the blade down, and then I'm going to call Søren's people at CNC Onsite, and they're going to actually have tooling, this amazing tooling, to drill out this old bushing and make it such that this Edo's wonderful refit solution can slide into this new drilled spot that's been perfectly honed. And this new bushing goes in, and there's a bunch of epoxy that's added behind it to hold that new bushing in place. And then once that's done, I move to the next one. And because the system is set up with CNC Onsite to go ahead and drill out multiple bushings very quickly, this process, once the blade is down, is actually very quick. So you're talking about maybe a couple of days total to repair a blade that otherwise would be discarded.
I'm very happy with this at the moment, and this is also with thanks to the criteria, to the cap measurements up tower we are doing. So this is the first step we have to do, of course. But thanks to that, we only need a limited amount of bushings. So we are doing, let's say, like 24 to 30 bushings are being drilled out. This takes us 24 hours, more or less. We are doing it, we could do it in 3 shifts, so then it's 1 day, but we are not doing it in one shift. They are working neatly, they are working accurate and with the same team, and so they are doing 3 days. After these 3 days, they are done with the drilling. Then we need to start the preparations. So the new bushings needs to be implemented. That will take us, let's say, like 8 hours of preparations, because everything needs to be vacuum tight, and that is essential for our solution. It needs to be low vacuum level, so all the air out. And then after this, that takes about 8 hours. And after that, we have the infusion day. That's a really exciting day always, because once the resin is running, we can't stop it anymore, right? So this day is also, let's say, 8 hours. So, and then we have some finishing, because it would be nice if we are hoisting up the blades again up tower, that the root is flat. Yeah? All the resin pieces are off, and we have to make sure that all the bushings are aligned well for the proper load distributions. Let's say another few hours, maybe 8 hours. So then we are 48 hours, 50 hours of the whole process, working with 3 or 4 people, and that's it.
Wow. And does it take anybody special to be on site from like the CNC Onsite? You know, CNC Onsite makes these great machines that are highly accurate. Søren, do you need to have specialized people on site, or are you training people that are local to do this work?
We are training local people, so that is part of the whole solution, that we do a technology transfer. So it's people are trained with this specific project. We started by having the team in Europe, so they had some training days with Edo and the guys in the Netherlands on the whole mounting and infusion technology, and then they came to our workshop and trained in operating the drilling machine afterwards. Then for the startup, we sent the technicians to the customer, who supported for a couple of weeks, and then we went back, and then we are basically always ready to support, but on Teams or whatever, we can set up a link and a system if needed, but they are running with it very well. So it's been very limited what we've had to do. We get some feedback on the drilling process, so we can optimize some parameters and step by step improve the process time. We've done some optimizations to the drills to make them last longer and do those things more efficiently, but they are basically running on their own.
Guys, I think that's something to make sure that we don't breeze over here as well, is the local content part of your solution. So you've done all of the expert engineering, figuring out the processes, of course, all the precision machining equipment from Søren's team as well, but you can export it to different locales and train up the local staff and get them moving. So places like, it's expensive, it's difficult to get people into South Asia. It's expensive, it's difficult to get people into South America, to Australia, to anywhere, really. You're going to export this. However, what you're also doing is bringing local jobs, local work, local revenue to the local teams. And I know that makes a lot of people happy, including, I know, like we're sitting in the States, right? There's a lot of ISPs over here, hopefully listening to this. They're saying like, ooh, we'd like to be the people that implement this solution over in the States. Let's get a hold of these guys. So kudos to you on that as well.
Yes, the idea is indeed to have on different regions in the world, different repair hubs, so that we can always work with the same teams, with the same people. So we train them, educate them, and then of course from the Netherlands and of course from Denmark, we will always support them. But it can also be done by a Teams or a conference calling.
Let's talk about the Southeast Asia project you just completed successfully, and it looked fantastic. That was the first major project that you've tried this technology on, besides everything in the laboratory, kind of one-off things, but now you're going to scale. This is a big step. How did it go? How did that process start? What did it look like afterwards?
How did it start? By doing it. I mean, Søren and his team went on site, of course, and we encountered difficulties, of course, first time with drilling. And that had multiple reasons. So the guys, even the colleague of Søren went back to Denmark. He fixed something on a drill, had sent a new type of drill, and it ran perfectly. So from that point, the drilling was no problem anymore. Then after we created the holes together, of course we have to do the infusion, and going from infusing like 5 bushings in a row, we had to go to 30 in a row. And that was in the beginning quite challenging to have. So it was a little bit like keep your fingers crossed if everything is going fine, but it works somehow. It works and all the resin came out. So we are quite happy with that. Of course, there are some fine tuning in the processing, in the quality, but that's important for us is to keep. You need to keep following the quality processes. If you strictly follow the quality processes, make sure it's vacuum tight. Make sure that you work in sections. So don't open your resin valves all at the same time, one by one, gradually. And then just monitor and make sure that, of course, refresh your resin from time to time, because that's a pot life thing, and it takes, let's say, like maybe 2 hours before the whole resin is going through the bushing and also in the depth direction that is being impregnated well. So you have to make sure that your pot life is under control. And also we work with a tent, which is like 100 square meters, which is air conditioned. And that all contributes to a controlled process. And yeah, that was very scary for the first time, I must admit that. If you do second time, you get more relaxed. And the third time, it's like driving a car. The first time, I need to pay attention to the gear. In Europe, we have gears and on the car, and we need to drive and look around us and the navigation system. And at a certain point, it's all going automatically, right?
How many blades did you repair in Southeast Asia?
18 now. Set number 6 has just completed. And I know this every week. I have contact with one guy there. We know each other good, so he gives us the feedback, and every week it costs me half an hour, not more.
It's usually not one blade. It's usually the whole set has an issue, correct?
Yes and no. What they do now at the moment, they see that one blade has a problem, so they already start thinking ahead by taking all 3 blades down. So even if 1 or 2 blades within the set does not have the variable capping, they know in half a year it will happen. That's the experience they already have. And there is a certain, they have a certain agreement here with the crane. The crane is coming, let's say they use a crane every month for a fixed period. So they say, let's hoist the complete set down. Then we have 3 weeks to repair. And in the 4th week, we will hoist it out again.
Yeah, and the technicians on site, once they're trained up, they're loving it, because whether it's in the hot in South Asia, or if you're doing this in the cold, you're working in a tank. So if they got an extra couple blades to work on as a blade technician, I'm all for it. I'm all for it. A little bit more time in the AC or in the heat, and nice kind of controlled facility. I think the guys will like that a lot in the field.
One of the benefits you get also is, as Edo mentioned in the beginning, if you catch it early, you have fewer bushings to repair. So if you catch it or repair it while you have your blades down already, you can repair fewer bushings. And in terms of process time, it's also a little bit faster. That's also what we learned, to drill out the bushings when they are not too loose. The more loose they get, the more risk you have of vibrations when you start drilling, and that can potentially damage your drills, and it just adds to the process time. So there are a lot of benefits by catching these things early and getting the process completed at an earlier damage stage.
Now you've completed your first big project, what's next? It sounds like there's a lot of opportunity worldwide to do this refit process.
Yeah, the first team is our number 1 team. You can see it also here on the breast, and we are now looking basically a number 2 team, which is as excellent as the number 1 team. So yeah, it's not only that we have to do. I mean, if you would like to have this technology implemented, it's going vice versa. So very, very important is that we are working together with teams, service teams, which 100% trust each other. That's where it starts already. And they are fixed. So if you have fixed teams, you teach them, and they learn by experience, and that's how it should be. So yeah, the next step is we are talking with different potential service companies worldwide. So we are talking within America with 1 or 2 potential good guys, good groups. The same in India, for example, and the same in South America. And that's our aim, to have, let's say, in South America, 2 service companies, in India 2 or 3, in India, in America 1, 2 or 3 or whatever. So we are now discussing with these parties, and it's not only one direction. Okay, we want to sell it to you. No, it's also the other direction. Are you capable? How do you want to work with 24-hour cycle? Do you have a place where we can install everything? So that's our next step, to explore.
Yeah, and Søren, you have to start making more machines.
I hope so. No, it's definitely, we've seen a lot of interest, and we've also had numerous contacts over the years. But again, it's been back to this: have this been done before? And it's sort of, no one wanted maybe to be the first, but now the first commercial project is out there. It's still ongoing, and once this is completed, we will have installed more than 1,000 bushings. So I think it's a decent proof of concept. It's a real case. It's not just one blade or one set. It's actually a larger farm that we will have repaired once this project is 100% completed. So it's going really well, and I think that, of course, there will, once the potential customers see that this project is now up and running, it will move forward with contracts for other projects. But who is going to be the first is still difficult to say, but I'm pretty sure that there will be more.
Yeah, we would also quite be keen on getting on the table with the big OEMs, because there are many parks which have still some kind of service contract, full service agreement or whatever. So even if many times park owners say to us, hey, we would like to have your technology implemented, because that sounds to be the most robust one. But you need to convince the big O&Ms. And sometimes that is a difficult part, because you need to go through this different steps with a lot of decision makers in these organizations, and that takes time. So request is on these big O&Ms is to define clear criteria for us. What should we fulfill, and if we fulfill this, basically, do we then have a deal with each other? Because in the end, for us, we need to help those park owners, because they are in the end they are feeling the pain on this kind of sometimes hidden problem.
Well, if you're an OEM or an operator, where do you start this process? Who do you call first? Do you call We4Ce or do you call CNC Onsite, or does it matter?
Call either of us, and we will make sure to involve the other part. So that's where the trust and cooperation comes into play. Just reach out, and we will set up joint meetings.
The website for CNC Onsite is cnconsite.dk because they're in Denmark. And the website for We4Ce is WE4CE.EU. And either one of those addresses will get you to the information you need about the refit and get you started, because as we've seen in the United States, a lot of things are changing, and worldwide, we need to keep these turbines up and running longer. The way to do that is to put a little bit of money into them now instead of spending a whole bunch of money later. This is why we love We4Ce and CNC Onsite, because they're saving operators literally millions of dollars. So, Edo and Søren, thank you so much for being on the podcast. We love having you. And as you finish up the Southeast Asia project, you got to come back on after you finish those 1,000 bushings and give us an update.
Absolutely. We'd be happy to.
Yes, thanks a lot. We are fully happy to.